In this second lecture, what I'd like to do is spend a little more time going over the course outline, giving you a little more detail, and showing a few more examples of what we're going to do in this class and more of a progression of how we're going to move through our development of computer graphics. Now, if you want to do this, follow this on your own computers. All of the examples are on my website under the WebGL 7E directory, so you can look at them now, follow along with me, look at the code later. And then in the next lecture, we'll actually take a simple example and go through the code in more detail. But for now, let's just look at how we're going to go through the class and how that relates to the book. So this week, and this will probably go a little bit into next week, we'll be dealing with chapter 1 in the book, answering the question, at least preliminarily, of what is computer graphics, what areas does it encompass, and I'll try to tack that through looking at some of the application areas in our next lecture. I'll also go through some of the history of how computer graphics has developed, because there's a very interesting intermingling of hardware, software, and applications bringing the pressure to develop new hardware and software, new hardware opening up the doors to new kinds of software, and going around in a cycle to where we are now. Once we do that, we'll then be able to address questions about image formation and very basic, as we said last time, looking at the human visual system and looking at very simple pinhole camera, but that's what we'll emulate when we build a 3D graphic system, and it'll get us into what's the basic architecture of a graphic system. That's all in chapter 1 of the text. The second part, we'll actually start writing some WebGL programs. In chapter 2, we'll develop all the basics in both 2 and 3 dimensions. We'll also look at, the job, they'll all, as we've said, be in JavaScript. We'll look at what some of the small changes you have to make from working in Java or C or C++ to working in JavaScript. We'll also have to talk some about what we do in order to execute on the web. The execution model will be somewhat different from how things are executed in the sort of the routine programming environment you've probably worked. And we'll do, as we said, both 2 and 3 dimensional examples, and we'll have to introduce shaders and the OpenGL shading language, GLSL. Now, primarily, what we're talking about there will be in chapter 2. It'll take us a couple of weeks to go through that material, but let me show you, I showed you a little bit of this last time, but let me come back to that and see if I can show you some examples again of what we'll do. So here's chapter 2, and for our first example will be to just put points up. That's known as the Sierpinski gasket. It's 5,000 points, which are generated by a random algorithm, but on the other hand, the shape that you get is not random at all. It's actually a fractal. We'll then look at how we can generate that same image using some recursive ideas. So let's look at this example, which is done recursively, where what we do is remove the center triangle, and then for the remaining triangles we reduce their centers and just recurse on that process as long as we like. And we'll look at it's a nice second example. Again, it's a fractal. It extends very nicely, as we'll see towards the end of that chapter, to a 3-dimensional version, where here's a tetrahedron, and what we've done is remove the center and leave 3 tetrahedron. I think you see here's one at each of the corners of the original 4 vertices, and then we keep subdividing that, and we'll see that 3-dimensional graphics is a very direct extension of 2D graphics, or more, to be more correct, everything we do is in 3D, and 2D will be a special case of what we do in 3D, and that's a very important conceptual issue. Then we'll come back and look more at the fundamental underlying mathematics and that we need to do computer graphics. So let me come back here for a second, and what we'll do in chapter. Let me move up. One is well, before we do that, I'm sorry. Let me come back here because we're working in a web-based environment. I think it's important to talk about interaction much more quickly. In the 6th edition of the book, we had taken out the chapter on interaction and just sort of sprinkled interaction around. But once you're working in a web environment, you will find that adding interaction to our examples is very, very straightforward. So we added a chapter 3 back in. We'll talk about that about the 4th, or hopefully I can do it in the 4th week of the class. And we'll introduce various models of how we can interact. What I find is that most of what we learn in the first couple of years of a computer science, computer engineering program really doesn't look at event-driven input. You do what's called request style input, where you enter something and you hit the return key on your keyboard, or you click a mouse button or something. But what we want is something much more dynamic and something that's driven by all the kinds of actions we call events that could happen. They could be mouse clicks, they could be key presses, they could be events that happen within the Windows system when a window is opened, or we iconify a window, or window moves in front of another window. So those will all be things that'll fit within a client-server model, and we'll talk about ways we can develop event-driven programs, which it turns out are very, very nice and easy to do with HTML. We'll also introduce various devices from the actual hardware kinds of devices like keyboards and mice, but also to graphical kinds of devices, menus, buttons, sliders, which again will also be easy to do. And then how do we get input from the screen, whether it's getting a position where the mouse is located and doing something based on that position, or perhaps pointing to an object and doing something based on the object that we happen to be pointing to. So let me look at a couple of quick examples of that. So that's all in chapter 3 of the text. So let's do one or two real simple ones here. So I have a couple of examples. One is a very simple one of just we learned to animate and to rotate things. So here's just a very simple example of a square rotating around, and a menu that lets me do things like change the direction of the rotation, change the speed of the rotation. So I'm interacting in a very simple way, and here's very simple devices that are not part of WebGL, but are part of HTML. And since WebGL works in HTML5, it's going to be very easy to add these kinds of things. And then we'll talk about a little more sophisticated kinds of interactions. Let's look at one more here. Here's a very simple one where what we do is we are just drawing triangles and learning a little bit more about color. And so every time I draw the first 3 points, I get a triangle, and then every additional point adds on a triangle connected back to the last 2 vertices, and also coloring it. Turns out is the default model, and so we can but you see, even though this is very, very simple, it has the basics of what you'd need to do a painting program or a CAD-like program, and again another very, very simple application, and we'll do a bunch of those when we talk about in chapter 3. Okay, now moving on, then we get to what I think of as really the core of the course, which is chapters 4 to 6, and that'll be the sort of the midpoint of the course, and there's really 2 or 3 major parts to that. In chapter 4, we discuss geometry, the basics of how do we represent geometry, how does those representations which will lead us to what's called homogeneous coordinate representations of where we go from 3 dimensions to 4 dimensions to do our manipulation, how that leads to transformations, the kind of transformations that at least you're familiar with, if not with the mathematics of it, but how we use those, whether it's a translation of moving something from one place to another, or rotating something, or scaling it, which want to talk about those kinds of transformations. In Chapter 5, we'll talk about viewing. What are perspective views? What are orthographic views? How do we do the mathematics for them and create the necessary matrices to carry them out within WebGL? In Chapter 6, we'll discuss lighting and shading. Until then, we'll use color, but we'll use it in very, very simple ways. And we want to have much more realism where we see very subtle coloring effects. Let me give you a couple of examples and work you through some of the things we're going to be doing in that. And that really is the core of the class. So let me come back here and look at a few examples. These are in chapters 4. So in chapter 4, we'll use a very simple cube as an example. And all this is a cube that's rotating in X, Y, and Z. It's interpolating the colors from the vertices across it. And so it's very, very simple, but at least we'll learn how to carry out transformation matrices. If we go back now and say, well, let's, what do we do next? Well, what we do next is, let's go up one and look at chapter 5 where we do viewing. So we'll talk about orthographic viewing, which is the simplest case. Let's see, look at this one for a second. And here we see a cube again in a solid color, and we're rotating it around. And what we're doing here is we're moving the viewer around. And you notice that there's only a certain region that we could look at, and that's why you see the back and the sides being what are called clipped out, because they don't fit within that region. And all of these things will be discussed here. I can make the region smaller and I can make the region bigger. And all of these are things we'll be discussing when we talk about viewing. We'll also be talking about different kinds of views. So here's a perspective view where let's do the same, starts off looking the same, but as I rotate, you can see the sides appear to converge because it's a perspective view instead of, and again, there's some clipping going on there, but it's a more natural kind of view. But again, as I mentioned, the coloring here is very, very simple. It doesn't look very realistic, and if we were to have some sort of curved object, that wouldn't look very good. So when we move on, we'll be able to do things like this. Here's a simple example of, we'll be able to talk about very simple shadows, where here's a single polygon and there's a light source somewhere up here, and what it's doing is projecting this onto the ground where we see this part in shadow because the light source, the polygon blocks the light source from this part of the ground, and the light source is rotating around. So we'll see some applications like that in chapter 5. In chapter 6, we move on and we'll be talking about shading. So let me give you at least 1 or 2 examples of that. So here's a shaded sphere where you see now, instead of seeing it in a solid color, this is actually built up of a lot of small polygons, but you see a more realistic kind of effect, and we can move the light source and we can do all the same kind of things. Here's a moving relative to the light source. You see part of it is not being lit very, very well. And all of these are things we'll talk about in chapter 6. Okay, now the other, really what I consider fundamental to this course is the material that occurs in chapter 7, which is all about discrete methods, which really are the dominant area of both research and hardware development over the last few years. So it involves a whole bunch of different things that we're going to talk about. One is, how do we deal with the various buffers you use in OpenGL? How do we affect those? A lot of that'll be examples where we manipulate images and do some simple image processing applications. But really the two primary things we're concerned with are texture mapping, where we can take fairly simple objects and make them look very complex by mapping images on top of them. And there are a number of variants of texture mapping we'll talk about. The other is and we'll talk on actually three things here. We'll talk about compositing things together. How do we add transparency? All the examples I showed you so far had surfaces which were opaque. No light could penetrate them, so you saw the front surface and nothing else. But we can make surfaces have some transparency. We'll talk about that. But the third one is a main thing I'm adding to this course, which is off-screen rendering. How do you do, sometimes called multi-rendering, of how you do multiple passes through the graphics pipeline to produce images that depend on other images. And I'll show you a couple of examples of that. Now, one of the things I'll focus on, because it's a lot of interest both in the department for various agent-based modeling things. A lot of things we do at Santa Fe Institute are getting much more important, and it turns out we can do them very, very nicely with WebGL. So let me give you one or two examples of that. So let's go to chapter 7. So here's here's a cube with a texture map on it. Well, that one has transparency, sorry. That has a little transparency so you can see through there. Well, it's a little faded out, but I think you can see the idea that we could actually construct images where we can see through surfaces. This is the one I wanted to show you. This is, I showed you this in the first lecture. This is a cube with an image mapped onto it, just a simple two-dimensional image, and there are a number of variants of that we can do. For example, let me look at this one. Let's see. This one is mapping a pattern onto it that we generate in the computer. There's a couple others in here. Let's look at this one. I think this is a nice one. This one is actually doing multiple levels of texture and having some sinusoidal modulations onto the texture. Come back, look at a couple other things we'll do. When we get to talking about off-screen rendering, let me give you one very nice example. Let me give you a couple here. Here's another one I think is nice. What this one is doing is a reflection map. This one is reflecting, think of this cube as being located in a room in which each surface, the four walls, the floor, and the ceiling, are each a different color, and this cube is highly reflective, and what's happening here is that we're seeing the reflection of the walls onto the cube. We'll talk about those kinds of maps. And finally, I want to show you this one. Rendering, yeah, let's look at this one. We'll talk about that later. Just 1 second. Now I guess I'm going to show you oh, here's the one I want to show you, sorry. Okay, these are a bunch of particles diffusing around, but you can see that what they're doing is they're changing their background. And in fact, the direction that they're moving is depending on what they read. So what's going on here is kind of a complex process where if you think of the model of this as being a bunch of ants, two different kinds of ants roaming around, and they leave chemical traces known as pheromones, that these are the pheromones that they leave, and the path that an ant coming along takes is based on what that ant finds down on the ground. And these patterns fade away in time and they diffuse. So this is a lot of things going on. There's about 200 independent agents moving around. It also turns out to be equivalent to solving a partial differential equation here, and one of the trends in computer graphics is actually using graphics hardware, GPUs, to do a lot of mathematical kinds of operations. And we'll be talking, hopefully have a lot of time to talk about these kinds of applications in the course. Okay, so let me go on, and then we'll just survey a few of the things. Once we're past this part, I think you're going to know an awful lot of computer graphics, and you should be able to pick projects at that point. If we go on in things, we're going to do more of a survey of in the class. I have this very nice section on procedural models and how we use hierarchy in computer graphics. Some of that will get us more into agent-based modeling, but in particular, I like to talk about particle systems, and that's a major topic in animation of how, for example, in movies, if you have a crowd scene, how do you get all of those people to move around? And what they'll do is treat each of the objects, a person, say, or an animated character, as a particle, and the particles interact with each other, and at the end they get rendered as people or animals or whatever you're doing. We'll also talk about robotic models, where the parts of the models depend on each other, and we'll build up some simple robots, and we'll also build up some simple figures that'll really be more animated kinds of robots, and we'll spend some time there. If we get to a little bit further, there's two things I've left out here. I sort of skipped chapter 11 in here. Chapter 11 talks about curves and surfaces and going beyond just working with polygons. I'll hopefully have at least a couple of lectures to talk about those basic ideas, and also that could be considered part of advanced rendering. But also, if we have some, I hope we'll have a little time at the end to talk about other ways of doing things, whether it's a ray tracer or some particle methods or radiosity. There's a number of methods that provide alternatives that can create even more realistic images than we're going to see in this course. So finally, just if you want to work through or look at a lot of these examples, just go to my website and run them on your browser. You can look at the code, play with the code, download the code, and make a few changes, and hopefully you'll see what we're going to be doing in the course.